point, it is 2 times 163, absolutely.
The integral would be 0 to 2, and then of s of x.
Don't forget parentheses and dx. Perfect. Good. Since we determined everything with the calculator, let's continue so we can move on to the next step. So I'm going to calculate the same thing. So I have 2 times 163, but minus. I'm going to copy. You don't have to do this. I'm just lazy. So 15x and plus 95. And this. Okay, so let's see what I have here to make sure it's correct. Oh, it did not even take that. Okay, so 2 times 163 minus. Good. So 2 times 163 minus the integral from 0 to 2 from 15x plus 95 dx. This will give us the producer surplus. So they are enjoying 106, meaning we should have not paid 2 times 163 because we're giving them for free $106 for 2 jumps. That's money in their pocket. Okay, now this time they say, okay, find the equilibrium point now and the consumer and producer surpluses at this point. Assume that he makes no more than 5 jumps. So they are capping it, not more than 5. Maybe we get 2 solutions. Maybe we get 4 and 15, but we only keep the 4. I don't know what we're gonna get. So in order to find the equilibrium point, of course, we have to set them equal to each other. So let's set them equal to each other. And we have 7.5x squared minus 60.5x plus 254 equals 15x plus 95. This is a quadratic equation, but we're not going to solve it with the quadratic formula. We're going to move everything to one side, clean it up. Minus 75.5x, and then plus, what is 254.95? 5? No. Yes, 5 and 1. So I got 159 equals 0. Is that okay so far? Yes? Yes? No? Okay, so let's go to, where are you guys? Let's go to, this time we go to apps. Number 9, polynomial root finder. It's quadratic, yes. Carefully enter the coefficients. 7.5 is the leading coefficient. Negative 75.5 is the middle coefficient. And the free term is 159. I need to clean it up before I solve it. So I got x equals 3. And x equals 106 over 15, which makes no sense because this is more than 5. And they told us not more than 5. So therefore, the equilibrium point is 3 comma, and that's one of the reasons why I was ready when I plugged it in y equals. I have the function, and I will plug in 3 to find the equilibrium point, the y coordinate of the equilibrium point. So 140. So therefore, This is the equilibrium point. And now the consumer surplus at the equilibrium point and the producer surplus at the equilibrium point. So it will be the integral from 0 to 3 from 7.5x squared minus 60.5x plus 254, of course dx, but minus 3 times 140. And the producer surplus is 3 times 140 minus the integral from 0 to 3 from 15x plus 95 dx. Now let's stop for a moment. Do we understand what is happening here? There are two simple formulas. If you understood how to determine the area above and the area below, where is my graph? This and the other one, there is a formula for each and it's done. So again, I'm going to use the calculator for this. Okay, so here's how I do it. Of course, you don't have to do this, but I always like to save time. So I'll do this. Second and previous entry. Second and previous entry. Aha. Okay. So I'm going to change 2 into 3. And I'm going to change 3 and 140. We check. So this is the producer surplus. 3 times 140 minus the integral from 0 to 3 from 15x plus 95 dx. 67.5. So we are leaving on the table, or we are giving them free 67.5 if we pay for 3 jumps at 140 per jump. Now we want the consumer surplus. Okay, here's the consumer surplus. I have to change 2 into 3. I have to change 163 into 140. But don't forget, I have to go back in front and change from 0 to 2 into 0 to 3. That's the one. So I don't have to type it in a second time. So I have the integral from 0 to 3 from the demand function minus 3 multiplied by 140, and that's it. And now when I press enter, I would get 137.25. We're not getting this amount, but we are enjoying it as if we paid for it. So it's an extra that we didn't pay for. Okay, so the consumer surplus and the producer surplus. And this is the end of section 5.1. Any questions? The other application, I know we have 3 minutes and you'll see the simplest possible problem in the next section, and I'll stop. In 5.7, differential equations. This is a major topic, but we're going to start with a very simple problem. First of all, what is it? It's an equation with derivatives. Equation with derivatives. And something else, but it has to have at least one derivative. Here's an example. First derivative plus 2 times the second derivative minus 3 times the function equals 0. This is an example. The first derivative plus 2 times the second derivative minus 3 times the function equals 0. This is a differential equation. An example. And a very simple example. And then I'll stop. Here it is. Just let me find the page number. That's 7. 535. Okay. Okay. Show that this function, problem 9, on page 535, show that this function y equals x natural log x minus 5x plus 7 is a solution of the differential equation. The second derivative of y minus 1 over x is 0. Okay, all I have to do is find the second derivative. So first I'll find the first derivative. Remember, this is a product. Very carefully. The first function prime is 1 times the second function plus the first function times natural log prime, which is 1 over x, minus 5. I simplify, and I get that y prime equals natural log x minus 4. Positive 1 minus 5 is minus 4. I don't need the first derivative, but I can't find the second derivative if I don't find the first derivative. And when I find the second derivative, can anyone tell us what we get for the second derivative? Natural log prime.
1 over x.
Good. Now look what I have to plug in. Is 1 over x minus 1 over x 0? What will I say? Yes, it is a solution of the differential equation. I checked.